I'm very happy to welcome Dr. Johan Mattsson today to speak to us about the Norwegian experiences of climate-relevant biodeterioration of historic wooden structures. Dr. Mattsson is a biologist and cultural heritage specialist and has a Master's of Science degree in mycology from Oslo University and an interdisciplinary PhD in building biology, building physics, and cultural heritage from the Norwegian University of Science and Technology in Trondheim. Johan is a leading expert in fungal damage and protection in cultural heritage, and is co-founder, chief advisor, and head of research and development at the Mycoteam consulting firm in Oslo, Norway, which is specialized in the field of biological degrading agents, including fungus, damp, and insects. Johan is a tutor at the International Course on Wood Conservation Technology in Norway, is also an authorized pest controller and approved for assignments offshore. And he is an expert member of the ICOMOS Polar Heritage and Wood Committees. One theme we're going to, we're hoping to follow and pursue this year is the potential impacts in climate change on our ability to protect and conserve wooden built heritage, including talks on interventions, methods, and new technologies available for mitigating those potential impacts and improving the climate resilience of wooden built heritage. Johan's talk today will serve as part one on this theme and is titled Norwegian Experiences of Climate-Relevant Biodeterioration of Historic Wooden Structures. How can we ensure optimal conservation in the event of climate change? He will discuss how a good knowledge of previous climatic and microclimate exposure to which old buildings have been exposed is essential for being able to understand where and why various biodeterioration have occurred. This understanding is also crucial to both clarify and understand how ongoing and upcoming climate change affects the risk of further biodeterioration in historic wooden buildings. And that's enough of me, and I'm sure everybody's going, yay. So, Johan, if you want to share your screen, and
yes.
we can start.
Yeah, I try that. Let's just remove some faces, and there we have the presentation, hopefully. Yes, thank you for your introduction. It's always interesting and amazing to hear about yourself presented in that way. So I got confused, who are you talking about? But I realized it was me. So I tried to do my best for this presentation as well. This topic is typically, many approaches to the topic, but as a biologist, I try to understand the causes for the biodeterioration and by this knowledge, how it normally occurs in buildings and building materials, then it will be possible to understand when it's something different happening, and by that possibility to difference between normal and abnormal development, we can start to understand what is the causes for this problem, and then again we can pinpoint the possibility for doing some efforts to avoid the further biodeterioration. As is mentioned, I work mainly in Norway, and typically you can find problems in all kinds of buildings, and so both heated and unheated buildings have different problems with the climate and also the climate changes. So we can see that the effect is, it's universal, but we are especially focused on the problems in Sweden and Norway, and in different parts of Norway we see variations, but still the same pattern of changing climate, and then also the change of biodeterioration rate. So, of course, we have to do a lot of field work to get this experience, but we also have to realize the similarities and differences between different building styles, building climate, building wooden materials. So we can see the pattern is quite often the same, even though it might be at the first glance very different climate conditions. So wood is very essential in many cultures and many buildings, and we can see that the wish is, of course, to achieve as long service life as possible of the wooden materials. But and of course, many materials are standing for a very long time without damages, but we don't know. We can't be sure in each case that it will be an eternal life. So we have to be aware that the risk is always behind the corner for getting a problem, and the climate change increases risk in some cases quite significant. We do, of course, we also always can find examples of building materials, building constructions that will stand for a very long time without so much damages. So of course, we can see that it's possible to achieve a long service life, but in other cases, it's not so easy, and we see that the damages are occurring quite fast, even though we wouldn't expect it to be that critical. So the problem is to well understand the microbiological activity, what is causing that, and of course the effect of is more easy to understand, that if the fungal attacks the wood and deteriorates the cellulose, the strength of the material is reduced, and the surface is also deteriorated eventually. So then we have a material that doesn't work as it was initially planned to do. So the result is what people normally observe, but they don't normally observe the causes, the reasons for this kind of development. So with bearing in mind that I guess I'm more or less the only biologist here, I try to make it a bit basic first. And this is as basic as it gets, because the plants, the tree, are making cellulose out of thin air, as a matter of fact, and water. And of course, with this energy consumption activity, we get these cellulose molecules and the long molecules that makes the wood materials. But of course, this is, if you invest in some energy, it's always possible to think that this is something that can be going to reverse, and that is the biodeterioration in practical sense. We have the energy from the wood materials by deteriorating that. The fungi and the insects also are getting energy as well as we get when we are eating food. So it's a quite natural occurrence of the decay of wood. So this is what the basic function of fungi and insect is, to reduce the wood to simple substances so that it can be reused later on. And even though cellulose might not seems to be very attractive, it is really what the fungi is try to deteriorate, as well as we have our favorites of glucose sources. So it's not necessarily very complicated to understand this if you have the basic knowledge. And this is what you really need to understand when it's changing, when it's not as normal situation. So the one main question is, of course, as always, is it okay or decay? But that is not necessarily so easy to answer, because it's a difference in different buildings and different climate areas. But often I think that doesn't have to be very complicated. If you see the well, take one mental and physical step backwards and try to see what is really the main causes of or reasons for any biodeterioration, then it's not so complicated, even though the people think it might be very difficult to understand. It's often very easy to do that if you have an overall understanding of the climate, of the building material and the exposure. So then you quite often think that is it really so simple? And yes, it is, because for fungi, the water is the main agent they need for heavy activity. So just looking for the wet parts of the material, what exposure, we have a quite easy way to at least find the critical areas, and by that have the main reason for what is happening. The challenge, of course, is that we have an experience, we have a knowledge of what's really normally happening, but of course, if they change the conditions, it might be a change of the reactions as well, and then we don't necessarily know what is the result. It's more unpredictable, at least at the start, when we don't have the long-term experience of what is the result of climate change. We have just a start situation, we have a glimpse of understanding, and for the future we're getting better and better and detailed understanding of this. So right now it's perhaps a bit uncertainty about the consequences, but still we can think that if the fungus is growing better, that's something that we can observe. If it's occurring in new species, we can observe and understand this. So hopefully it's so basic, so we can figure out what's happening quite early in the process. But of course, the question is, what is the possibilities to reveal this? And normally we have this building survey. We go out to the building and we observe for some hours and we try to understand what's the situation, and then we predict the future. And of course we can see what has been happening, but we don't really know what is the future just by observations from one visitor to a building. So it indirectly we can see what if it's some deterioration, we can understand what has to be the reason for that, but not necessarily that we understand what is the situation for the future just by observing the old damages, even though they are an excellent information source in many cases. So first of all, we have to find the risk areas and where is the highest risk for any new development or further development of biodeterioration due to climate change. And of course, it always has to be a bit complicated to find the critical areas and to get access to that part of the construction, the part of the building. But usually it's possible to do that more or less easy if you have the right mental thoughts about how it would be done. But because there is a possibility to see the highest risk for development due to the building physics and the effects of the climate exposure and the climate change. Typically in crawl spaces, we see that you have this water, the damp situation from the ground, but also this summer condensation problem when it's warm, damp air come into the cool crawl space due to ventilation, and then we have a change of the relative humidity due to the lower temperature, and then it's a risk for quite common and extensive damages of that construction. This is something normal happening, but if we also see that the climate change is increasing that risk and increasing the damages that are occurring in that kind of construction. So the main question is often that, okay, we see how it has been working up to now. In this left picture, well, it has been successful so far, but will it continue to be successful with this quite damp conditions? So it might be a risk that you cross the border and then suddenly it's too wet and then it starts to decay by fungi or insects as well. So we have to understand what is the risk for the future just by experience, and that is not necessarily the best way, as I will tell you later on. And it's extra difficult when you have this situation with some established damages. In this right picture, it's an old, inactive attack by dry rot fungi. And without any change of the conditions, that could be stayed untreated for many years in the future. But if it's getting a bit wetter, a bit higher temperature, it might be a risk that this fungi that is in dorming state, it might be waking up and start to grow again. So we have this risk both in sound constructions and also where you have some old damages, that it might be an influence that the climate change can influence on the risk for further future development. And how much do we have to remove of old damaged materials in order to be a bit more safe, or do we have to do that at all? So it's a lot of questions that's not easy to find a simple solution, a simple answer, because it's so very much depending on the local conditions. And also it's often very, in general terms, we say it's getting warmer and wetter, but that is very very little help for understanding what's really will be happening in the microclimate. Because if warmer, is it warm in the summer or in winter or in the fall or in spring? Because if it's warmer, it might be drier because it dry out more of water from the soil, and also more humid climate. It's a bit difficult to really apply that to buildings because it might be just a small change that is not any critical for the building. So in order to understand that, we have to start monitoring the situation so we know what is really happening and what is really a risk for these changes. So some places in Norway it might be more rain, and other places it might be less, and the temperature might increase in the summer or the winter. So we have a lot of uncertainty of this general information. And also it's some general illustrations that has been used that is nice for politicians or for just a general understanding, and but it's useless, to my opinion, to the understanding what is happening in this building, in this room, in this crawl space, because that is something that has been, the Sheffer index, for instance, is made for the outdoor exposed wood. It's not the same as a wood in a floor construction or in a roof construction. So we have to understand that these models, climate models, is not it's not useful at all for understanding the risk of biodeterioration in buildings and building materials. So even though it looks very fascinating with these maps with different colors through time, it's not something that we should take too much efforts to read about. On the other hand, if we go into the microclimate, then we can be very interesting, because then we can see what's really happening in those specific materials, constructions that has some history. We see what the condition is right now, and we can see what will happen if it rains more on this log wall, if it blows more, if it's a higher temperature. Then we can start to really pinpoint the risk for different activities, or perhaps reduced activity due to the more wind and drying out the water from the materials. So microclimate is the really essential understanding we have to bring into these thoughts about what will be happening with the buildings. So this is something that I have a very special heart because that is basically my thesis I made 7 years ago. And if you haven't read that before, you can, if you send me an email, I can send an electronic copy to you at least. And perhaps if there's something, you can place it on some website. It's okay for me also, because I think it could be nice for people to understand more about the biological approach on these microclimate conditions. And this is about the World Heritage Sites at Bryggen in Bergen, and in the west coast old town Lærdal with house longhorn beetle issues, and also at Røros, the World Heritage Site of Røros, a city in mountain area, and also the Svalbard. And in these areas, especially in the cold areas at Røros and especially at Svalbard, we really see the climate change is something that's happening. So it's a higher temperature, it's longer, a shorter winter, and longer growth season for any plants that might be in that area. And of course, if you have a fungi in a log construction and it's not freezing cold most time of the year, then it's a higher risk of biodeterioration. So just send me an email to Johan at Mycoteam .no, so I can send you a copy later on. We have also made one paper about that, monitoring climate change. So you might find some more information in that paper as well. But as I mentioned, these climate models and also the general information from governmental institutions is often very general and very, what to say, it doesn't really learn the reader so much about the real effect of the climate change. It's more or less in general, it's getting warmer and wetter, and then it's focused on it might be more decay, it might be more insect activity, so be aware. But that doesn't really help me as a house owner be aware of what and how can I really be in front of that development. So this kind of information is not enough for really handling the risk of biodeterioration in old buildings. It might be said that you have to do more maintenance outdoors, but of course that is not very different from what you might do already. And so there's a lot of question you might have that is not answered in that kind of information brochures from governmental institutions, at least not in Sweden and Norway, which those I have read. So it's not enough for handling this. And of course, it's depending on what is the risk. It has been a lot of discussion in Norway in this autumn last year about the extreme weather conditions and what effect might that have on building and building damages like biodeterioration. And this is an illustration that, of course, if you have a flood situation, it doesn't really influence on the biodeterioration. It's a short term. It might be physical damages and all that kind of problem, but as for a mold might be raised risk, but the others, it doesn't matter if it's wet for a couple of weeks or something like that. If it's rain and a more intense rain and more amount of rain, then of course it might be some increased risk for mold activity on exposed surfaces at least. But the others doesn't really have that kind of immediate response on extreme weather. But of course, if you have a longer period with rain, so the materials doesn't get time to dry out, or if you have a longer period with increased relative humidity, then it might be very typically, you can see the mold damage is occurring quite fast. And the other is, but it takes years before you can find wood decaying damages, fungi causing damages, or the insects. So it's not an immediate crisis if you have some extreme weather, or at least in the start of a climate changes, but it might be a potential risk in some typically low risk constructions from before, because it might be changed so much that now we can start to get problem with, for instance, mold growth. And we have this general understanding of the building physics during summer, winter in unheated attic or basement or crawl spaces, but those are very general, so it doesn't really make any sense for the actual risk in my building or my crawl space or at the museum. It is in a general dotted line here for the critical risk for mold growth at a certain relative humidity, but that is a general level. We see that many of those mold damages we have now that seems to be connected to a climate change is by species, xerophilic mold species that grows at lower relative humidity than that 85%. So it's this is in general illustration of a risk situation, but it's not any practical use of that for understanding what's really happening. But if we start monitoring, we can see the this is from a project we have in the old church, and we can see the relative humidity, and still we have the same line of risk for mold growth. And we can see that a lot of the time is actually above that line. And then we start to think that, well, that should imply that it's a lot of mold growth on every surfaces and every materials, but that's not true. So this theoretically and semi-practical revealing of facts is not very easy to handle, to understand what is really the risk for this. So, and also the wood moisture content that should imply that you have some decay problems in wood, and still it's not the same risk in practical sense as this logging results suggest. So we have to understand that the reality, the biology is much more variations and local variations in buildings. So it's not easy to really say this is a clear risk and this will happen. We can now we make it more in general terms. But you see this typically fungi that is a early sign of something that's happening. This Aspergillus species that is typically a xerophilic species that can grow well, like the 68 to 70% relative humidity in otherwise good conditions. It's not happening very fast necessarily, but it's if you see those fungi starting to occur in a building, then we realize now it's something happening, especially if it didn't have that kind of attacks earlier. So the understanding, the information we can get out of a damage, if it's a wood decaying fungi, if it's some insects or some mold fungi, then we can see that if you have that species growing there, we realize that that is a biodeterioration monitoring device, this fungi. So we can get a lot of information what has been the reason for this activity just by understanding the biology. So it's important to really look into detail regarding the actual damages and not only remove it and curse the fate that you had this kind of damage. We have to really realize that this is an excellent information source for understanding what has been happening so far. So it's not necessarily difficult to understand what is the activity. We really have to realize it has to be four main reasons for at the same time in order to have a risk for biodeterioration. It has to be wet, and some nutrition, some favorable temperature, and long enough time for development. And then, of course, then we can understand by looking on these 4 factors, which one is the reason that we have a lot of mold growth on this spoon in an unheated storage building, lying on a wooden table. So then we can realize that the temperature is the same, the humidity is the same, the time exposure is the same, and so the only thing that is really might be the explanation is accessible nutrition. And then we can realize that this spoon has some remains from the porridge from 1700 something. So that then it doesn't have to be a large effort to avoid mold growth in that storage. We don't have to install dehumidifier or something like that, or heating up, or some extensive treatment. It just have to understand that it might be just a small efforts that has to be done to avoid that kind of mold growth. And we see that commonly that it might be small variations in material properties that causes or avoid damages. Like in this case, that it's an old floor that has been in a damp basement for 150 years without any damages, and it was repaired due to some external water intrusion, and the new wooden materials had no problems in the first 5 months, but in some other materials, this oriented strand board material has extensive mold growth at the same exposure time as the other materials. So we have to understand that some risk is not universal, but it's very depending on the material properties. So then we can see that, okay, we have some fungus. We understand the building physics by just reading the biological literature. And otherwise, we have other species, and we realize what has been happening here. It's typically summer condensation. And that is what we really find then if you go out to this church, then you got, as a matter of fact, a Norwegian sentence at the top you can try to understand. And I guess only Anna is the one who's really reading that. But this English in the rest of the text, so I can understand that we can see a different part of the construction have different kind of damages due to the building physics and the micro environment. So in one part it might be a summer condensation problem, and the other part of this area is typically winter condensation. So we have to understand it's not one problem and one solution. It might be complex. We have to look into details in order to find the correct observations and correct evaluation and correct efforts in order to handle this. But of course, it's interesting when you have an old church has been more or less the same conditions there for many, many years. And then in one summer, last summer, it got quite extensive mold growth on some of the surfaces. So of course, then we can see that summer 2023 was extreme to one sense, because now it was some new damage that hadn't been there before. But we don't know if this is a start of a climate change, or if it's a start just by a very rainy summer. So then we have to see on the timeline what is really, is it the physical changes, and does this develop furthermore next summer and next summer? But at least we have a starting point that we didn't have that kind of damage previous time. And other buildings that has been used and moved out for many years ago, we can see that it's starting to get new damages that hasn't been there earlier. Traditionally, it was no mold on these sooty surfaces up in the roof construction. But in later years, we see that it has been extensive development of mold damages on certain surfaces. We can understand it by the building physics why it start grows there, but it's very hard to understand why didn't it grow there for 50 years ago, 100 years ago, but just the last years. And this is really a sign of a change that is going on. And since it has been raining a lot previous times as well, this might be a typical example of early warning sign of this climate change that is influencing on the biodeterioration. Especially when you see this, follow the pattern of the specific species that grows at low relative humidity compared with other mold fungi. So this is a first critical signal of damage development, which we should be aware about. Was not correct. So this project where we have gained this experience from Norway is a project that Directorate of Cultural Heritage in Norway started 6 years ago. And it's supposed to be running on for like 50 years and might not be possible for me to write the final report, but at least it's interesting to be a part of the start in this project. It's about not only medieval buildings, but it's 45 buildings here in Norway that has been examined, and also we have this monitoring activity. And these buildings, we have one monitoring up in the attic and one as low as possible in the building, in the crawl space or under the floor, if it's possible. And they are spread around as much as it was possible due to different reasons in Norway. So we have different kind of buildings, we have different kind of weather conditions, and then it's possible to find the similarities and differences in more by like statistic analysis. And then we can try to understand what is the, as I said, similarities and differences between a wooden building and a stone church just right beside the wooden buildings. Can we see a pattern of the damage development due to climate change, or is it so much depending on the construction material and the microclimate in one single area that it's not possible to compare those two buildings even though they are just a few hundred meters apart? So what we have installed in all this building, this panel of both monitoring the temperature and relative humidity, and also the moisture content in wood. And this is standardized wood blocks that is used all over the project and also in some buildings in Sweden. So we know that we have the same conditions, the same nutrition in the wooden blocks. It's very, very unified, these conditions. So we see that the A is relative humidity and the temperature, B is wood and moisture content, C is pine sapwood blocks, and the 4 of them, and then we have pine heartwood and 1 block of oak and heartwood. So we can both compare with different kind of materials and also different part of Norway. And then we regularly take first after 1 year and then after 5 years take tape lift samples on the surfaces in order to see if something has been established and growing on the wooden blocks. We didn't have so much thoughts about how fast it would grow, but at least we have some standardized method to monitoring and to see what would possibly be of any damages. It's very kind of Stone Age. It's not something you see on the telephone, but it's very reliable because it's all over Norway, and it has to be so simple, so robust that we can understand that this is really working. So we place them in both low and higher part of the building, and we see if we get some activities that difference in different buildings, and not necessarily just decay, but also the mold growth, for instance. And we can see that it has been surprisingly fast growth of many wood blocks by mold fungi and this specific xerophilic mold fungi. So we can see that this is really happening so fast. And then we have both biological monitoring by the growth, and we all have the physically monitoring by the instruments here. So then we can compare very much what is really happening, where it's growing or maybe not growing. And we have this monitoring data from temperature and relative humidity. So we can start to see what is really happening here and what is the difference from other buildings and similarities. And then we can see how the pattern is of different mold fungi and how extensive the damage is. So we're starting to getting some results that we will publish eventually, but now we have to struggle with all this information. But in short term, we can see that already in very short time, we can see that in crawl space, it might be extensive mold growth on these wood blocks, standardized wood blocks. At the same time, it's no growth in the attic conditions. And we can see the pattern of the fungi is very typically for different kind of building physics. And it's typically that summer condensation conditions that is dominating the pattern of what has been already after 1 year. So you can see the pattern, and then it's very predictable what we expect to find on these wood blocks and these conditions. And that is a very good understanding, but because we don't have that from earlier. Now we can see that this is typically some very significant species that occurs in buildings on different surfaces on different part of the building, and that then it can be used to recognize if something happening that hasn't been before. And of course, we can compare with how does the old wooden materials work out in this changed climate compared with new wooden materials. So we have taken samples from the old wooden surfaces just close to this panel exposure, and we can see that it's typically first in this picture you can see that in each square here you can see that the color is changing from 1 to 5 years. So it's a clear development in many different buildings, both down in the crawl space and also up in the attic. So in general, we see that the wood blocks has a very good possibility to record the ongoing risk, mold growth risk in the constructions. But we also, when we take these samples from the materials beside, we can see that it's typically that we have a pattern both in what kind of fungi growings of the new materials and how small attacks there are on the old materials. So we can see that comparing old materials might be very difficult because they have different origin and different treatment, different historic exposure. But if we compare this with new standardized wooden block, it's much easier to see what is happening in different part of the building, in different part of Norway, and then we can see, is it really some pattern of climate change due to this growth we have? And so it really is possible for us to see now that this logging device gives us a possibility to see how the microclimate is connected to meteorological data from far away from the building, and then we can see how well is it possible to predict the general effect of climate change and what is happening in the detail in each building, in each area. And the fast, quick growth of this xerophilic mold growth is also very interesting because it gives us a very clear pattern of the critical start of reaching the critical moisture content, moisture relative humidity conditions. And we can also start to see the variation of the possible climate change in different geographical position, different kind of buildings, and different part of the building as well. So this gives us a very good unified knowledge of the risks in different buildings that we haven't been able to achieve with just a single survey from one building to another, because it's very much depending on the person going out in the building. Now we have the objective information from wood blocks, from monitoring, that gives us a reliable and comparable information. So, of course, it has been so early in the project, we don't expect, and we haven't found any wood decaying fungi in these standardized wooden blocks, but eventually that will be a clear risk for the future. And of course, it's also, we don't expect any insect activity in those materials, but since we know that the insects are requiring some microclimatic conditions, we can start to predict the risk for both house longhorn beetle and common furniture beetle in nearby other wooden materials in the area. So we guess that this will have an practical impact for the evaluation of buildings in the future. But of course, it's not something we see very fast. So we have to understand that this is something that 5 years, 6 years is not enough for really have all the answers. But we see that the possibility to get an early warning sign with these panels, with the biological monitoring and the physical monitoring, is something that really have given us some new information that we didn't have from before. And even though we have been working with this for 35, 40 years, this is something new that we haven't had available earlier. So from this kind of momentarily observation, we see something and we interpret it to be our typically climate change causes. It might not be that, so we can avoid this kind of miscalculation of the reason and the understanding, and put the focus on this facts we can achieve from these climate panels. So we think that we are really working in the right direction now in order to get as good and reliable information as possible in order to find out what is happening and what can be done in order to reduce this humidity exposure back to a more normal condition. So we are quite excited about this possibility for really pinpoint the risks in different buildings, and also the possibilities to compare this with over larger geographical areas. So we think that this is something that could be used in other places as well, in order to find very simplified and very unified information that is not just by looking at some old materials that you don't have the history knowledge about. Here we know exactly what is the background, we know what's happening, and we can observe it in very early stage. So we can see this is something new happening, and this is something that we have to be aware about in order to be able to save the old materials in the construction where this panel is exposed. So I think I just stop there, and I haven't had any questions so far, but hopefully you have something now.